Hi, my name is Rajesh Valluri and welcome to my video. In this video, I'm going to walk you through the process of using YOLO 4 weights, pre-trained weights to do some object detection and inference on your laptop or on Google's Colab. So many of you probably have heard of Alexy's YOLO 4 object detection algorithm. There are many resources on the web to learn about this state-of-the-art object detection algorithm, including my own YouTube video from a few months ago. If you're keen on playing with YOLO 4 without delving too much into its guts, this is the video for you. In this video, we're not going to go into the actual architecture or the design or the training methodology or any other stuff. We're just going to um, use it as a tool, as an application to test it out basically. So what we do is we install the application, we download the pre-trained weights, and then we use some of our own pictures to see if Microsoft's if the model actually picks up objects found in those pictures. Before we go any further, I would like to advise you that and Colab comes with distinct advantages, like it's free of cost, doesn't cost you a dime, and then if you have a Google account, you have a Colab account, and it comes with really powerful machines like 16 gigs of memory is guaranteed, and very high powered NVIDIA GPUs are guaranteed, and you can use them for almost a day at a stretch without paying anything to Google. However, unfortunately, the one downside is you cannot store any of your models or any of your work after the timeout period is reached. After you have allocated your time for the day, you are either forced to log out, or when you log out of your own, there's no way to save any of that work on cloud. You have to either download those things onto your laptop or you just lose them. And then when you start over the next time, you have to start from scratch. That's the one downside to using Colab. But if your intent is to just test out something and see if it's something that you would like to pursue, then yeah, Colab is the best way to go. It takes all of 10 minutes to do this from end to end on Colab. So let's tackle that first, and then once we're successful, if you still want to, you can learn how to do it on your laptops or your desktops. So let's start with Google's Colab first. So like I said, Colab is free. Just all you need to do is to go to this URL, which I'm going to post down below. So colab.research.google.com, and then when you go there, you just say create a new notebook, and that's I so what it does is it provides you with a Jupyter notebook, as you can see here. This Jupyter notebook, there's a couple of things I would like you to do first. So go to runtime and select manage change runtime type, and you need to pick GPU, and there's also option for TPUs, but we're not getting into that now. So just use GPU and then save, and then you get a new session, and yeah, all set. So the very first thing I do is just to see what's going on, either ls minus ltr, which just tells you the fact that you're able to run this command means you're connected and you're good to go. Okay, so like I said, first thing, you need to download source code from Alexy's GitHub, which is done by this command, git clone .NET.git, and so you do this, you run this command, and it will download the files, the necessary source code onto your onto Colab's drive that's just been created for you. And once it's finished, you can see that the files are here. See, under .NET, under the folder .NET. So .NET is the actual network, and YOLO 4 is the algorithm. You only look once. That's a whole different story. What the name behind what's the name and what object detection is and all of that. There's like literally tons of research involved in it, and YOLO 4 is a culmination of a number of years of work done prior to it. So if you want to learn any of that stuff, yeah, you need to do a little bit more work. But if you just want to play with this, keep watching. So once you have this, the source code downloaded, the next thing is I normally check for what kind of hardware was assigned to me by Colab at this point. So this is usually give or take the same, unless you're on a pro plan. And I also like to look at the folder structure by running this command, which is the same. I mean, you can see it on the left hand panel right here. It's the same structure: build, config, blah blah blah. We'll get into that later as we start using it. And then the first step, the next step is to cd into this .NET folder or directory. Go there and just look at the, I don't have to look at the make file. I mean, there's a make file has lots of directives, compiler directives, which we don't need to get into at the moment. The only thing we need to change is these four settings. GPU is changed from 0 to 1, which means we are telling the compiler to use GPU. And CUDNN is also changed, allowed to 1. And yes, again, CUDNN have is enabled, and then OpenCV is enabled. OpenCV is a computer vision library that's used to like create files and open image files and create image files and that kind of stuff. So that's what we use OpenCV for. So when we change these four settings, we are ready to compile the .NET. So just run this, and you can see there's it takes a couple minutes to build. That's done. Then we just scroll down, and yeah, so we have the model ready to use, but what we don't have at this point is we do not have the weights. So we need to provide the weights for this model to work. So what we do is again get these weights from GitHub, from Alexy's repository. So you can see here that the weights have been downloaded. So let's go and double check where those weights are. They usually here under the root folder of .NET. It says YOLO version 4 weights. That's the one we just downloaded. So yes, so once we have the model compiled and the weights downloaded, and then we are all set. But we just need to double check one other thing. So how it works is .NET, the way Alexy wrote this code is it can have it can do more than one thing. It can be used in it can be used as a object detection model, or you can play some other games. I don't know exactly how many things it can do, but it can do a few things. So one of the things is object detection, and even within object detection, you can use it in two ways. One is to train, and the other one is to inference. So in this case, we are using the inference. So when we do either training or inference, we have to tell the model a couple of things. We need to tell the model what kind of classes have we either trained the model for, or are we going to infer based off of. So in this case, these weights, the YOLO V4 weights that we have just downloaded, are trained for Microsoft's COCO common objects in context. That's a data set. It consists of 80 commonly used objects, commonly found objects, and Alexy has trained his model on those 80 different classes. So this model can only detect things as long as they fall into one of those categories. So these are just the things that we need to be cognizant of, because if we try to run a picture by this model which does not contain those 80 objects, either our results will be either incomplete or in some cases incorrect. So it may take a shape which is closest to an object within the model, within the training set, and say, oh, this is what it is, but it may be well off. So we just need to be cognizant of the fact. So Coco dataset, this model works, these weights work for the Coco dataset, and the dataset here is actually in the config folder, coco.data. You can see clearly that there are 80 classes, which means there are 80 different objects, and the actual data is in data coco.names. So let's go and find that one. Coco, sorry, data, not in config, data, and coco.names. Here we go. So if I open this file, you can see that these are all the different things, all different objects, quote unquote. A person is not an object, but yeah, and you get the idea. So what we have here is a bunch of things like parking meters, bench, bird. Bird is like a standard bird. Anything with wings and two legs is a bird. That kind of stuff. So this is not this classification is fairly broad, but it just is not meant for very fine tuned detection. So that for that we need to do something, a different thing. We need to train our own models, which you can do. I have a couple of videos for that as well, but yeah, so this is pre-trained models. So yeah, close these two files. We don't need to keep them open. And now let's yeah, I think the moment of truth is here. We can just upload a file and then test it out. So in here what I'm trying to do is let's upload a file first into and then we can run that file by the model. So here you can see the darknet is the compile application. It's using detector. So there's, like I said, it can do a few other things, but here we are using to detect objects. So detector and then we're not training, we're actually testing. So testing, and again these are the other directives. So we're using the coco.dataset, and then the weights are here, and the configuration file is here, and the actual file in the test image is here. So I think I did a dog.jpg. I used a dog.jpg when I did this like a while ago, but right now let's find something interesting. I have a file called kitchen.jpg. See, this is a beautiful beautiful picture because it has a little bit of everything. It has some chairs in it, some table, some lamps, a microwave, oven in the back. There is a person, there is a jug, there is a potted plant, all of these things, some of which actually belong in the Coco dataset. So with any luck, our model should pick them up with, and then give them the high probability. So let's try this one out. So what we need to do is we need to upload this file, and kitchen, and once we upload it, takes a few seconds, and then here we go, kitchen.jpg. I'm gonna copy its path, and then I'm gonna use it in this inference command, where you see these are the following things that we provide at the command line. So darknet itself is the name of the program, and detector is the mode. Like I said earlier, there's a few modes of operation for this model. Like it can play a video game, I mean not a video game, a game. It can do a few other things, but in this case we're using it as a detector, object detector. And then the next argument or parameter is whether it's training or testing, which is test in our case, and then the dataset, which is coco.data, and the configuration file YOLO V4.config, and then the weights, and then the actual file itself. So let's replace this file with the one that we want to test, and then let's remove this don't show directive as well, because it actually uses OpenCV and shows us the results. And then let's run this. There you go. So you can see in real time that the model is processing this file, the image file, and then it has loaded the weights. So the good thing about this model is these weights are replaceable. So if you have trained a different model, and you want to use those weights, you can use them here, which I'm going to show you how to use these different models downloaded from various sources some other time in a different video. But yeah, it's very flexible that way. And now you can see that already you have a potted plant 91%, person with 98%. So these are the things that some of the things that the model has detected in the image we have supplied it. And it has created a predictions.png file for us to oh, not compile with OpenCV. Don't know what happened there. We're supposed to compile with OpenCV earlier. Let me double check. Yeah, see here, minus I OpenCV equals 0 to, I don't know what happened there. We'll get to it in a minute, but later. But yeah, let's see if that image actually um, let's open the predictions.png file and see the results for ourselves. So this is predictions.jpg. There should be a predictions.png as well. Yes, I don't know why it says png here and jpeg here, but basically yes, it's the predictions.png file. There you go. So you can see it has put bounding boxes around each of the objects. It has picked up this woman as a person with 98% probability, and in the back it picked up this plant as a potted plant with 98%. And if you actually see how cool this is, it actually picked up the little vase thingy in the back, and it actually said, oh, I think it's vase, but only 38% probability. And then these two chairs are close to 100%. Again, oven, microwave, another oven, and it's a refrigerator, even though it's only partially in the field of view. So yes, beautiful. So there you go. So you can use Colab to build YOLO V4 and actually test it out, and it takes less than what, 10 minutes, less than 5 minutes to be honest. And yeah, that's the best. Yeah, that's really exciting. Now if you, for most people this is enough, this is good enough. You can try playing with different kind of images and all of that stuff. Like if you have a bunch of Google images, in the Jupyter notebook I supplied, and in the description below, you can actually do multiple images at a time instead of just one. But yeah, you get the idea. This is all on Colab. So if you still want to go to the next step, next part, in which I want to show how to do it on your own laptops or on your machines, that's actually I prefer doing it on our own machines, because if you want to build an application, like if you want to build a cool app of sorts where you can capture these pictures and run them off of and then do something else with it with the detected image, it's best if you can do it on your own. I mean, you can still do it on the cloud, Amazon AWS or Microsoft Azure or something, or even Google has some paid options, but if you just want to build that proof of concept, then it's best if you can just do it on your laptop. And in the next part of this video, I'm going to show you how to do just that. Stick around. Let's try to see if we can actually run this same thing on a personal laptop or a desktop of your choice. So the big difference between Colab and your personal laptops is most people, including me, we do not necessarily have high-end GPUs on our laptops at our disposal, which is okay, because we don't tend to do a lot of training on laptops, because we offload that to cloud. Cloud tends out to be cheaper, especially if you use the free tiers. So that's okay. I have a 32 gig memory machine, 32 gigs of memory, and a 8th generation i5 processor, which is okay, which is not terribly great, but it's not really that bad. This is good enough for the inference part of any image detection or image processing project. So what I'm going to do is, before we go any further, we just need to make sure that we change a few things, the way we do a few things on your laptops, because on Colab we have told the compiler not to actually use a GPU, and then we also told the GPU to use CUDA libraries, and we also told it to use CUDA CNN and then OpenCV libraries for the image part of the thing. But except for the OpenCV, we cannot use the other three if you are not using an NVIDIA GPU. So so when we are using the compiler directives, we are going to skip those three things. So without talking further, I'm going to fire up the Jupyter notebook on my laptop. I have my machine is actually Linux Mint, which is I think a fork of Ubuntu. They're all pretty much the same. I'm not going to go into how to install Anaconda or Jupyter Notebook or any other stuff, which is they are fairly straightforward. The only thing I would advise you strongly is to use a separate environment for any each new project you use, because the Python versions and various libraries are sometimes contradictory to each other between projects. So if you build a project and then you try to do something else, and you install new libraries, they may actually break the older one. So keep them compartmentalized, and that way all your projects can coexist without breaking each other. All right, so let's fire up Anaconda Navigators. So I'm using a Linux operating system machine, but there's absolutely no difference between Linux and Windows. For instance, you can use Windows 11 or Windows 10 or any version of Windows that's at your disposal. Now I can show you. I have created this YOLO environment. That way it has its own libraries. So yeah, you might run into a problem when you're compiling it for OpenCV. The OpenCV that ships with Anaconda is uh, is a higher version than the one used by YOLO, so that might cause grief. But so this is 342, OpenCV 342. But if you run into it, just drop me a comment or just Google for some solutions. There are some straightforward solutions that you can use. What I did instead was I actually used I installed a older version of OpenCV, which I'll show you later if we need to do that, if you need to do that. But yeah, just be mindful of that. If you that's the one thing that you most likely will run into when you're trying to do this. Okay, now go back to home and fire up Jupyter Notebook. And once the Jupyter Notebook is up and running, let's begin the process from scratch. So new Python 3, and then just go through the similar steps as before. Clone the repository by typing in this command. Yeah, and then run this. Yeah, it's downloaded, it's finished. The next step is to make changes to the make file, which is, let's do a pwd first. Yeah, I'm here, home Rajesh. So if I do a ls darknet, yes, I have darknet directory. Home Rajesh darknet. Okay, now again we need to make changes to the make file. guy. Now cat make file. Yeah, there you go. OpenCV is enabled, the rest of them are not. They're untouched, so this is good. We're getting there. And again, now time to compile. The compile component is fairly straightforward. Just say type in make. Okay, so the compilation has been successful. Now the next thing is to actually download the weights, if you remember, and let's do that. Yeah, YOLO V4 weights are done. And again, so what we need to do is, because we do not have the same directory structure as what we have on Colab, we just copy the command, which is this guy, Control C, and we just modify it to suit what we're going to do here. Control V. Where is this kitchen file? It's in here. Downloads. So I just need to use this path instead. Okay. See how hard it is for when you take the GPUs out. It takes a while. It takes significantly longer than otherwise. So if you want to run this as a real-time application, maybe you should consider getting a machine with GPUs on it, or just find a way to run this on the cloud. But yeah. There you go. Beautiful. So this is the same picture as before. Similar success rates with the percentages on everything. Fridge, microwave. So the actual quality of detection doesn't change. It just takes longer. If you want to see how long it has taken exactly, if you check here, the prediction took on my machine, on my laptop, it took me how many milliseconds? 56,000 milliseconds, give or take. And for the same effort on Colab, it took 19,300, yeah, 19,200 milliseconds. So let's say this is rounded to 20, and this rounded to 60, yeah, 3 times as long. So yeah, so that's okay. I mean, as long as you're only doing it for proof of concept, we should be happy with it. Yeah, that's it. And what I want to show you next is these are the images from these are the objects from the Coco dataset. Like I said, you can also extend this to use different datasets and different pre-trained weights. What I'm going to show you next is, actually I have done a project a few months ago where I trained a model on a bunch of birds that come to my backyard, and then using those weights, I ran some inferences on pictures I taken, which is pretty cool actually. There's a video showing that. So what I want to do next is to actually use those weights, and everything else is the same. The weights will change, and the config file will change, and the data file will change. Other than that, the rest will be same. I'm going to put the links for the GitHub location of the weights and the config files and the data files. And yeah, you can download them and try them out on your own if you're interested. So as a bonus, once you have finished all of this, I would like to give you my own weights, the weights that I used to train a model of birds detection. So the context is I have a bunch of a big backyard where a bunch of birds come in every day, and I thought like how cool it would be if I can train a model, machine learning model, to capture those pictures and see what bird is in each of those pictures. There is actually a separate video that I made, a three-part video I made about how I came about. I went about training the model, doing all of that work. That's a separate video, but I'm just going to make them available, the weights and the configuration files available to you on GitHub. I'll post the links below, and then you can just try them out yourself with any picture from containing birds in it. But no, it's only a handful of birds. Like there's like 5 species of birds in that model, so it's not terribly refined, but it just gets it's just a fun project that I did. So those weights and the config files will be available down below, and I'm just going to show you what you need to do with those files. So the first file you need to download is birds.data, and you need to put that in in the config directory. If you're doing it on your laptop, it's just like in the darknet folder. It's right here. If you okay, create a test directory here in the root folder directory, and paste a couple of create a couple of test files, which in my case look like this. So these are the pictures I have taken from my backyard. So these two are called lorikeets here in Australia, and this is called a kookaburra, and these two image files are present in the tests directory. And because I have trained my model based on the assumption that the pictures will be one of the 5 images, one of the 5 bird species, so the model works here. So if you need to download the following 4 files: birds.names, birds.data, birds.config, and YOLO V4 birds.file, the weights file. So these 4 files are actually available on my GitHub. You can download them. I'll post the links below. And once you download these files onto your machine, then move them across to the right folder. Birds.data and birds.config actually go to let me see, data goes to config, and these 2 files go to the config folder. So let's take them and put them in the config directory, and the next file will birds.names belongs in the data folder. So let's go here, one level up, data folder, and finally the weights file, which is this one, goes in the root folder of darknet directory, root directory. There you go. Now we should be good to go. Let's go back to our Jupyter notebook, not the cloud one but the local one, which is this one here, and let's kick off the run. So just make sure that you have the files, the configuration files in the right place, the weights file in the right place, and you have created a tests folder under the root directory with some pictures there. So you can download these pictures as well if you want from my GitHub. Now let's kick it off, and voila, darknet is doing its thing. Takes a while to load the weights, and then oh, you know what, final. I think I made a mistake, because this is Linux and all. It follows it's case sensitive. I need to change that again and try again. Change that and try again. There you go. hopefully it goes through this time. Still running. You can see from this asterisk here and this hourglass here, so just be patient. Beautiful, there you go. So my model has worked, and it it detected this little beautiful creature called it's called kookaburra. This is an Australian native bird. And yeah, so you can try this out. Let me know how it goes with if you actually do in fact end up trying with my dataset. And the way to run this in Colab is identical. You just need to download the weights, and everything else is the same. So give it a shot. Let me know how you feel, and if you have any questions, or if you run into any obstacles, either on your running it on your laptop or on Colab, feel free to reach out to me. And yeah, let's see how it goes. Good luck, and if you like this video, like and subscribe and share. Thank you very much, and good luck.